Good afternoon, friends. In second day of webinar, I Chirag Savalia welcome you all participants. Now I would like to request to our enthusiastic Vice Chancellor Nitin Pethani sir to say few words.
नमस्कार फ्रेंड्स, सौराष्ट्र यूनिवर्सिटी और आर के यूनिवर्सिटी के संयुक्त प्रावधान में जो वेबिनार का आयोजन किया है वो वेबिनार के इनॉग्रेशन सेशन में हमारे बीच में जिनकी प्रेरक उपस्थिति है वैसे हमारे प्रो वाइस चांसलर डॉक्टर विजय भाई देशानी, हमारे सिंडिकेट सभ्यश्रियों, डीन श्री और हमारे साथ जुड़ी हुई आर के यूनिवर्सिटी के एग्जीक्यूटिव वाइस प्रेसिडेंट श्री निमेश भाई पटेल, विविध स्थान से हमारे बीच में जो पार्टिसिपेंट है, स्टूडेंट्स है, उनका ज्ञान का तृप्त करने के लिए जो मेरे तज्ञ जुड़े हुए हैं, वैसे आज के जो एप्लाइड फिजिक्स के बारे में कंसेप्चुअल बातें रखने के लिए जिनकी प्रेरक उपस्थिति रहेगी और उनका ज्ञान का लाभ मिलने वाला वो प्रोफेसर ओम वत्स, स्पेशल एजुकेशन एंड रिसर्च फाउंडेशन अहमदाबाद में हो डायरेक्टर के रूप में क्रियान्वित मिलने वाला वो स्पेस साइंस के बारे में स्पेशल एजुकेशन एंड रिसर्च फाउंडेशन की जिज्ञासा को संतुष्ट करेंगे। आज के दिनों में से वो शुरू किया है वेबिनार 4 दिन चलने वाला। ये 4 दिन में हर रोज 4:30 PM to 5:30 PM तक हम साथ में रहेंगे और दिनों में हमारे साथ जो तज्ञ का लाभ मिलने वाला है वो हमारी फैकल्टी प्रोफेसर डीजी कुबेरकर, डिपार्टमेंट ऑफ नैनो साइंस एंड एडवांस मटेरियल, सौराष्ट्र यूनिवर्सिटी का HOD है, वो अच्छी तरह से मटेरियल्स फॉर न्यू टेक्नोलॉजी की जानकारी उनके पास है। सारे स्टूडेंट्स को उनका लाभ मिलने वाला है। और तीसरे दिन हमारे बीच उपस्थित रहेंगे डॉक्टर मुकेश रंजन, वो FCPTI गांधीनगर का साइंटिस्ट, वो प्लाज्मा फिजिक्स पे उनका मत रखेंगे, उनकी बातें रखेंगे। और चौथा दिन हमारे बीच SVNIT का एक जाने माने असिस्टेंट प्रोफेसर बहुत अच्छी तरह से वो अपनी बात रखते हैं, वो डॉक्टर योगेश सोनवाणी जी सिमुलेशन टेक्निक के बारे में वो अपनी बात रखेंगे। दोस्तों, मैं अपनी तरफ से यानी सौराष्ट्र यूनिवर्सिटी की तरफ से एक पूरा 4 दिन का जो वेबिनार है वो वेबिनार की सफलता चाहता हूँ और शुभकामनाएं देता हूँ और धन्यवाद और अभिनंदन करता हूँ दोनों कोऑर्डिनेटर को, जो डॉक्टर सावन कतबा आर के यूनिवर्सिटी से जुड़े हुए हैं और डॉक्टर आशीष रावलिया जो मेरी फैकल्टी है सौराष्ट्र यूनिवर्सिटी की। दोनों का कोऑर्डिनेशन अच्छा रहेगा और हमारी जो हमारी पूरी फैकल्टी और छात्रा के लिए ये बात पूरी यूजफुल रहेगी। और आने वाले दिनों में जो मेरी कंसेप्चुअल एंड अप्लाइड फिजिक्स के बारे में जो भी बात रखे वो अपने लिए उपयोगी रहकर हमारी जो अभ्यास के बारे में बोले तो ज्यादातर ये लाभदायी बनेगा। वैसी हमारी कामना है आप सबको और मेरी तरफ से यूनिवर्सिटी तरफ से शुभकामनाएं चाहता हूं और पूरी वेबिनार की सफलता के साथ हमारे साथ जुड़ी हुई सब फैकल्टी को मैं धन्यवाद भी करता हूं और अपना ज्ञान का लाभ अच्छी तरह से हमारी यूनिवर्सिटी को और शिक्षा जगत के साथ जुड़े हुए सबको मिले, ऐसी शुभकामना के साथ मेरा ये बात पूरी रखता हूँ।
Thank you, Nitin Pethani, sir. Now, I would like to request to our highly energetic Pro Vice Chancellor, Vijay Desani, sir, to say few words about our university.
Namaskar. Good evening, friends. Respected Vice Chancellor of Saurashtra University, Dr. Nitin Pethani, sir. Respected Head of the Department of Nanoscience, Dr. D.G. Kuberkar. Respected Shri Danish Patel, Executive Vice President, RK University. Dr. Mayank Pandya, Director, School of Science, RK University. Professor Om Vats, Space Education and Research Foundation. Dr. Mukesh Ranjan, Scientist, FCPTI. And Professor Dr. Yogesh Sonwane. Dear participants, my syndicate members, all team, and the most respected speakers. Hope you will be fine and safe at your home in this lockdown period. First of all, I welcome you all on behalf of my university, Saurashtra University, the first grade, A grade university of Gujarat. We have here affiliated 237 colleges and 29 departments in our campus with 2.25 lakhs students. Our faculty and students are doing a lot of research work here, and we are also running a IS/IPS training center in our campus. It is amazing, within very short time, our nanoscience department of Saurashtra University and RK University of Rajkot have arranged a very successful webinar for 4 days. We will see more than 15 states. Students from more than 15 states are taking part in this webinar. And within a very short time, we have received more than 1900 registration from the students. It's a great thing. I congratulate the Nano Science Department of Saurashtra University, particularly Dr. D.G. Kuberkar and RK University for this event. Saurashtra University, it's a good news for us. There are 877 Indian Higher Education Institute. There was a survey by UNIREC. Out of that 877 institute, Saurashtra University stood at the rank of 98th. It is pride for us, and for that I congratulate all my department heads, teaching, non-teaching staffs, my syndicate members, senate members, the principals of affiliated colleges, and this has been possible under the dynamic guidance of our respected Vice Chancellor Dr. Nitin Pethani sir. Thank you all again. Stay home, stay safe. I would like to suggest 3 things. First, wear a mask. Don't go out of your house without a mask. Wear a mask. Second thing, keep social distancing because we are passing through our corona pandemic. Second thing, social distancing. And third thing, they very much important, wash your hands frequently. Namaskar. Thank you all.
Thank you, Desani sir. Now I would like to request to our young and dynamic Dean, Dr. Mehul Rupani sir, to say a few words about the webinar.
नमस्कार। सौराष्ट्र यूनिवर्सिटी की ओर से और साइंस फैकल्टी की ओर से मैं डॉक्टर मेहुल रूपाणी साइंस फैकल्टी के डीन के रूप में आप सभी का हार्दिक स्वागत करता हूं। आज अवसर का पीरियड है और लॉकडाउन है। हम सभी लोग हमारी सेहत के लिए पिछले 1 महीने से संपूर्णतः अपने घर में सुरक्षित हैं, लेकिन विकास के लिए ऑनलाइन माध्यम से हम सभी लोग कार्यरत हैं। सौराष्ट्र यूनिवर्सिटी के द्वारा नैनो साइंस डिपार्टमेंट के द्वारा काफी कम दिनों में ये जो वेबिनार का आयोजन किया है और इतना बड़ा प्रतिसाद, अप्रोक्सीमेटली 1900 पार्टिसिपेंट्स पूरे भारत से रजिस्टर्ड होना, ये काफी बड़ी बात है, उत्साहवर्धक ये बात है। और इसके माध्यम से ये लगता है कि हम सभी लोग अपने पर्सनल डेवलपमेंट के लिए काफी एग्रेसिव हैं। आने वाले दिनों में भारत को कोई नहीं रोक सकता, ये जो बात है, ये जो अवधारणा है, ये सिद्ध होने वाली है। विश्व को आज भारत पे मीट है कि इतना बड़ा देश और इतने कम केसेस, ये जो हमने एक मैसेज पूरे विश्व को दिया है, ये भी काफी मोटिवेशन है बड़ा। नैनो साइंस डिपार्टमेंट के द्वारा आयोजित इस वेबिनार में आप सभी पार्टिसिपेंट्स का स्वागत है। और खासकर जो 4 हमारे स्पीकर्स हैं, ये काफी वेल नोन स्पीकर्स हैं। प्रोफेसर ओम वत्स सर, हमारे ही सौराष्ट्र यूनिवर्सिटी डिपार्टमेंट के हेड प्रोफेसर कुबेरकर सर, साथ में डॉक्टर मुकेश रंजन सर और डॉक्टर योगेश सोनवानी सर, आप सभी का सौराष्ट्र यूनिवर्सिटी की ओर से, साइंस फैकल्टी की ओर से स्वागत है, क्योंकि आपके माध्यम से पूरे भारत को, सिर्फ 1900 पार्टिसिपेंट्स तो वेबिनार में, बाकी ये फेसबुक में भी लाइव होने वाला है, यूट्यूब में भी लाइव होने वाला है, तो इसके तरह इस माध्यम से मैक्सिमम लोग आप सबको सुन पाएंगे। तो आप सभी का स्वागत है। और अप्लाइड फिजिक्स, बेसिक साइंस के ऊपर ये जो वेबिनार है, ये सभी लोग इससे कुछ न कुछ हासिल करें, ऐसी मेरी आप सबसे शुभकामनाएं हैं। और इस अवसर को ना चूके और पूरे जितने जितने भी सेशन हैं उन सेशन को अच्छी तरह से आप लोग एंजॉय भी करें और कुछ ना कुछ इससे हासिल करें। और लुक अप, लॉकडाउन नहीं, लुक अप, ऊपर देखना और ऊपर देख के आगे बढ़ना, ये अवधारणा को हम सभी लोग सिद्ध करें, ऐसी मैं शुभकामना व्यक्त करता हूं। भारत माता की जय। अस्तु। वंदे मातरम। नमस्कार।
Thank you, Mehul sir. Let us welcome Professor Om Vats. Om Vats is the Director of Space Education and Research Foundation, Ahmedabad. He has published 118 research papers. He has worked on research program in several centers, for example, San Diego, USA, KSRC, Japan, INP, Brazil. So I would like to request Om Vats to share our knowledge to us. Please, sir.
I am very thankful to the organizers of this webinar series, both from Saurashtra University as well as RK University. And it is indeed my pleasure to share some of my experiences, my work with several students of these two universities and many other universities as well. And the space science is a very interesting topic. And with Rajkot, I have had a very big connection in terms of even doing research work, interacting with the students and faculty of Saurashtra University. We even used to have a radio telescope in the physics department of Saurashtra University, where from several students from Saurashtra University have done their master's program and PhD program, and several research papers have been written on that. And it is indeed on behalf of PRL and on my personal behalf, I thank always the Saurashtra University for this such a nice collaboration with Physical Research Laboratory in the past. And even before this collaboration and even after the collaboration has ended, I have been a very regular visitor to Rajkot to give talks in the Saurashtra University, in the Community Science Center, and several programs. I really enjoy being there. With this webinar, which is now organized during this time that most of the people have to stay at home, through this platform, they will be able to participate in this academic activity from wherever they are, not only in India, even from abroad, people can take part in this program. So this is a very good platform that this has. And now I request Dr. Sawan Kataba to start the presentation. And once again, I thank the organizers for the.
Hello friends, we have with us Professor Om Vats, and you can ask your question in the chat box. Sir is monitoring all the questions, and he will give all the answers at the end of the webinar. So let us start our presentation.
A very warm welcome to all the participants who are taking part in this program for the discussion on space science for us. The word space science I used here includes everything, all entire space from Earth to all the way to the boundary of cosmos, which is the microwave background. So we will talk about some aspects of it in some detail. The details have two limitations. One is my own knowledge about all this, the vastness of space, and the other one is time. I am Om Vats, and this is my email address. I nowadays work for this Space Education and Research Foundation, whose website is also shown below. And this foundation is mainly working for popularization of space science. And in last 2 years or so, many talks, many programs have been conducted by this Space Education Research Foundation, and the information on all these is available on this the website of the foundation. I encourage every one of you or all of you to take advantage of this. Now, before I start the discussion on the space science, let me bring to your attention the very simple, very interesting, and not very voluminous reading material for space science. And these are available freely on this website. And these, in fact, are basically cartoon books, and so simple that you really understand the subjects like aurora, cosmic rays, geomagnetic field, global warming, ozone hole, polar regions, solar wind, upper atmosphere. I myself looked at this several years ago and found them so interesting that I then decided to translate all these in Hindi. And the Hindi version of these books is also available on the same website. And today, these books are so popular that they have been translated to many international languages: German, French, Russian, Portuguese, and several. Of course, originally these were all made in Japanese and translated in English. I read the English version and got interested, and since then I recommend this to all the students wherever I get an opportunity to interact with them. Now let us discuss on the products of space research today. I don't think that in the world today there is anybody who is not using some aspect or the other of space research products. Almost everyone uses the some product or the other, or many products of the space research, and they can be broadly classified in several ways. But the way that I felt appropriate is the following: the information, the amount of information that the space research has provided to us today by the efforts of large number of institutes and scientists all over the world. We know considerably good amount of information about our Earth, its atmosphere, its upper atmosphere, its magnetosphere, and its interplanetary medium, our own natural satellite, that is Moon, and many of the planets of the solar system, Mars and Venus, Jupiter, Saturn, and all that. We know considerable amount of information is there on asteroids and also the comets, which are also considered to be the life and the atmosphere bringing stuff to the Earth for the creation of atmosphere and creation of life on Earth. So all this information has come out from them. The education part today, you can go to several websites and several browse for any educational material on the internet, which also is basically a byproduct of space research. And you can learn history, you can learn languages, you can learn geography, you can learn science, math, any subject, anything that you think of. You can learn technology, you can learn how to repair different gadgets and how to assemble, how to make. Lots of this information is available because of the space research. And the communication part is even more important and more used very widely. And one of the things that I am sitting at Ahmedabad right now, and you all are sitting at different places in your houses, offices, or wherever, that you all can listen to me and interact with me, ask questions on this, is because of the space technology that we have, which we call information technology or IT today. The prediction aspect of space research also have considerably improved, though there is a need to make it even more accurate, more accurate and more precise. And like today, sitting anywhere in the world, you can find out what is the weather of a XYZ, any other place, whether it is a hill station or a island or a continent or anything. Everywhere you can, and not only that you can learn what is today's weather, you can also learn how it is going to be in the next 1 month, 2 months, 3 months, 10 days, all the information, though the accuracy of this may still be limited. But there is a lot of information which is reasonably accurate are available. Let us do some discussion on this comfort aspect of the space research. In the past, for many of the things, we need to go from one office to the other office, one shop to the other shop. Today, by sitting at your home and looking at the internet, and many of the big companies, big firms, and they have their own website or their own apps. Through that, you can find out all kinds of things which you can even buy online and get them delivered to your home. You don't go anywhere. So that's the kind of comfort that it has provided. You can book tickets, you can book airline ticket, you can book bus tickets, you can book taxis, you can book your hotels, go anywhere. So that is the comfort that we all enjoy from space research. Now, I will try to give you some glimpses of the different parts of the space research. And there, I will give more emphasis on the topics that are more familiar to me. And here, I have shown 2 examples, one here. And this is a comet. In my childhood, I had seen comet, but was not knowing what the comets are. We used to call them Puchhal Tara, a star that has tail. But today, with the advent of so much knowledge, almost everyone knows that they are not stars, they are comets. They are objects of the solar system. They reside almost at the boundary of the solar system, and when they have a very highly elliptical orbit, and they come very close to the sun and then goes very far away. When they go very far away, they accumulate dust and water there, and they're icy objects. But when they come closer to the sun, the heat from the sun continuously sort of melts the icy
surface of the comets. And not only it melts into liquid, it also vaporizes it, and the ionizing components, energetic particles of the sun also ionizes it. And the continuous pressure imposed by the sunlight makes this tail, which is shown by this white color. This white color tail is called dust tail. It is not ionized. It's just neutral material, but it is pushed away from the sun, in the direction away from the sun, by the pressure of the light, the photons coming from the sun continuously hitting it. There is also, along with the light and heat that we get from the sun, we also get magnetized charged particles, which we call solar wind. And this magnetized charged particle takes with it the ionized part of the comet and makes what is called this blue or iron tail, which is shown by this greenish blue color. And this also, a lot of studies of this, the various comets have been carried out in the past. And such things, the solar wind not only affects comet, it also affects the planets. Like this is our Earth here in the center. And our Earth has a magnetic field, which is more like a dipole field. If the solar wind is absent, is not there, if the field will be symmetric on the day side of the Earth and the night side of the Earth. It will be dipole structure all around the Earth. But because there is a continuous bombardment of the solar wind coming from the sun side, which is the day side of the Earth, the magnetic field lines on the day side of the Earth gets compressed, and this night side magnetic field lines get largely expanded, which we call as the magnetotail. And they could be hundreds of Earth radii, whereas this side could be only 5, 6, or 10 Earth radii distance, very small distance. And not only that, these magnetic lines from the day side of the Earth are pushed, some are even broken and then made to flow backward. And that creates this cusp region that you have here. And through this, the highly energetic charged particles can enter, and they come to the atmosphere of the Earth near northern pole and the southern pole on both sides, and create what is called aurora. And some plasma that flows along with this magnetic lines of force, but when they meet there, the charged plasma also get sort of trapped in it and flows backward, and again comes to the polar regions on both sides and creates the aurora. So these are, and this not only this kind of effect is seen on Earth's magnetosphere or Earth's, for the Earth, it is also there for various other planets. So that way, these are the information that the space science or the space research have brought to us. Now, let me go to another aspect which is more familiar to me, is the observation of sun. The sun is called the astrophysical laboratory, and this is our star, or the nearest star that we see, and it can be observed in various wavelengths. Like here, this is the kind of sun that we see, the photosphere in visible light. And the chromosphere and corona of the sun in the past, we were able to see only during total solar eclipses. But today, the technology, space technology, have advanced so much that anytime you can observe the chromosphere of the sun. These are chromospheric images of the sun in ultraviolet and H-alpha emission. And these are at a temperature of thousands of degrees Kelvin. You can also make observations of the transition region of the sun, which is even higher temperature, an order of magnitude higher than the chromospheric temperature, and you can get images in the helium 2 lines and extreme ultraviolet, many of them. And then the outermost region, which was earlier visible only during total solar eclipse, also there are ground-based systems. There are systems on board the satellites, and they make the observation of sun in various wavelengths. The corona has a temperature of 1 to 20 million degree Kelvin, and it gives radio emission, extreme ultraviolet, and X-rays. And these are some of the typical examples that you see of the coronal images of the sun. And these images have been used for various kinds of study. One of these study that our group in Physical Research Laboratory and several collaborating universities have done is the solar rotation. And in a very simple way, to learn about solar rotation, you can look at these two images of the sun. This is on day 1 solar image, and this is after 3 days on day 4 sun's image. And on this you see these spots. These are called sunspots. They are here, and similarly on here. But the interesting thing is that here on day 1 image, you had a spot here, which was very close to the limb. But 3 days after, this has gone behind. This has disappeared. These spots or group of spots were almost in the center or very close to the center of the sun, have moved now towards the limb, going outside. These which were on the east side of the center have moved close to the central region. This feature, which was very close to the eastern limb, has moved inward. So this all indicates that sun is not a stationary object that we may feel while looking at it, but it rotates. And this rotation can be calculated by using these images. You can calculate how many degrees this feature from here to here has moved, and from that you can determine the solar rotation. And a lot of studies of this have been done. In fact, as a matter of fact, these observations were made, initial observations were made by Galileo more than 400 years ago. And he used his optical telescope to look at the sun. And with that, he derived that the sun has rotation. It is not stationary. So he was the first person to say that sun rotates. And later on, some studies were carried out, but then this field was thought to be not very interesting. But in the recent past, in last 15, 20 years or so, there is a lot of emphasis on the study of solar rotation, especially the differential rotation, that the sun at the equator rotates faster, at both the poles it rotates slower. And because of the differentiality of rotation, if there is a poloidal, very weak poloidal field on the surface of the sun, that poloidal field will get converted into toroidal field. And with continuous rotation, several rotations of the sun, the magnetic field lines or the loops will get twisted, and after a while they may break, and those magnetic loops will then appear in the form of sunspots on the solar surface. So this is this kind of scenario that is now being building up. and then they disappear because of the surface flows, and also they disappear, and again the residual weak poloidal field remains, and again the process starts of making new set of sunspots and things like that. So with this scenario, the study of helioseismology, which gives the information of the interior of the sun and the rotation of the interior of the sun, which is also now known, and it is very complex. And similarly, the rotation of different outer layers of the sun has become very important, and considerable amount of work on this has been done. And I will talk a little bit about some aspects of it. There are basically three methods of measuring the solar rotation. The solar rotation, the first method was the tracer method, in which you use sunspot. Initial sunspots were used by Galileo, but later in the recent years, plages, filaments, coronal holes, faculae, bright point, etc., have been used to measure the rotation period of the sun. Later, in the spectroscopy, the field of spectroscopy was developed, and it was possible to make a spectroscopic observation of the sun, because sun has several emission lines coming from different regions of the sun, and by doing that spectroscopy, because one side of the sun, when it rotates, the one limb is coming closer to us, the other limb is going away from us. So one will be red shifted, the other one will be blue shifted. So because of this differential shift, Doppler shift of the spectral lines gives you the information as to how the sun is rotating. A lot of considerable work on this also has been. This method is a bit subjective, so has slightly more error. This method is very accurate but very tedious to work on. In about 20 years back or so, we started a method called flux modulation method. On this we have done considerable amount of work. And in this, the flux modulation method, we have used disk infiltrated flux of the sun, we have used radio images of the sun, we have used X-ray images of the sun, we have also now recently used the extreme ultraviolet images of the sun, and some of the examples of this I will show you in the next few slides. But let me summarize at this point the present basic knowledge about the rotation of the sun, which we call it the differential rotation of the sun, is that the equator of the sun rotates around 24-25 days. And if you go towards the north or to the south pole of the sun, the rotation period increases to as close as 34-35 days on both sides, here as well as there. Now, let me, since this is our method, let me tell you a little more details about this flux modulation method. And the basic analysis procedure is shown here in this diagram. That what we do, we take the solar image of say a day, and on that day we put these lines, these strips, make strips on the sun. This is the equator of the sun. And at every 10 degree we make these strips, and along these strips we get the average intensity from the northern side as well as the southern side. And like so, the whole image is now converted into 17 if we do this at every 10 degree. So we get about 17 data points, 17 intensity values, one for equator, one for plus 10 degree, 20, 30, and so on. Similarly for -10, -20, and -30, and so on. And and we do this work for today's image, tomorrow, day after, and roughly for a period of about a year, we do this. And by doing that, you get the series of this type, that this time series of intensity variation generated for each latitude has this kind of way. Here on this axis, you have day of the year, and on this axis, you have the flux intensity of the emission. It could be radio emission, could be X-ray emission, or could be extreme ultraviolet. The image that you use will be that. And you see that it has these fluctuations. And you can clearly see that in these fluctuations, you do get a feeling that there are regular peaks and dips, though there is associated noise because of the solar atmosphere, because of the instrument, and could also be because of the path in between the sun and our observing station. So all these noises also are there. But you do get a feeling. This is an example of 1999 for 20 degrees south, and this is for 20 degree north. But if you analyze this series and calculate the autocorrelation function, which is given by this formula, and vary this lag L to 0 to several hundred or so. If you have a 1 year data where you have 365 series data points, so you can go to a lag of 100 or 150, and you plot this autocorrelation function as a function of lag. And here in both the examples are shown. This is for 20 degrees south and this is for 20 degree north. And in both these yellow figures that you see here, you see that the autocorrelation begins with 1, falls down, and then again comes up, goes down, falls. So these modulation, these regular periods that you are seeing here is because of the rotational modulation on the intensity. So it basically removes the noisy part of the sun, which is aperiodic, and picks up only the periodic part and gives us the observed rotation period of the sun, which we call synodic rotation of the sun. And that synodic rotation is then converted into sidereal rotation. We remove the effect due to Earth's rotation around the sun, and that we call as the sidereal rotation period of the sun. And from that you can make this kind of diagram. And here on x-axis you have latitudes, solar latitudes, and 0 to plus, that is the northern high latitude, 0 to 80 degree. Similarly, from 0 to minus 80 is the southern latitude of the sun. And on y-axis you have years, and the colors that you see here filled are representative of the sidereal rotation period. This dark blue color means 24-day rotation period, light blue means 25, green means 26, and yellow is 27, and red is 28. And the contour plots that you see here, that here it is red, that means the rotation period is high here and rotation period is low. At the equator, the rotation period is low. All the values from this year to this year, if we average, we get this continuous line curve. The scale for the line curve is shown here. This 24.8 days to 26.4 days. And this is the sidereal rotation period in days. And this period that we are discussing here, from 92 to 95, it is the decreasing phase of cycle 22. This work is published by Vats and Chandra in 2011. And so what is interestingly shows that the equator, the rotation period is least, which is good. And then on both sides, there is increase. But this increase is not symmetric. So this we call as the asymmetric rotation of the sun at that particular region of the solar atmosphere, where from this emission comes. So the rotation period of the southern part is higher. That means it takes longer time to go around, and the northern takes less time, so that rotates faster. And if we go to the next phase, it's like this is the decreasing phase of cycle 22. And so at the end of, say, end of 96 would mean that that is the end of the cycle 22, and then cycle 23 will begin from there. And this is the increasing phase of the cycle 23 from 96 to 2001. And in this increasing phase, you have the latitude on this axis, you have years on this axis, and the color code is more or less the same, which represents the sidereal rotation period. And you very interestingly see that the equator everywhere rotates, takes less time to rotate, which is mostly dark green or light green. But if you go on either side, it turns into red, yellow, and red, which means that there is an increase in rotation period. And if you take the average, that is shown by this continuous line, and that shows that in this phase, in the increasing phase of cycle 23, the rotation period is symmetric. It is not too much different in northern and southern hemisphere. If you go to the next part of the cycle 23, which is the decreasing phase of, say, from 99 to 2005, that is the decreasing phase of cycle 23, and you do the same analysis, make the latitude versus year, and the color code is slightly different in this, because this information has come from the radio images of the sun from the ground. The other two were X-ray images from the space-based Yoko satellite. So here again, but the color code still indicates that the rotation period is higher here and less in comparison to the northern side. And if you take the average, which is shown by this continuous line, the rotation period of the northern side rises slowly. The rotation period of the northern side rises fast. So there is the period. So the northern part rotates. It takes more time, rotates slower than the northern. So this has given half cycle information. So from this, we tend to believe that this sun has a asymmetry in rotation, and this rotation asymmetry is also not always fixed. This changes from one part of the cycle to the other part of the cycle, and it seemed to have a periodicity of about 22 years. So, and recently we also have done another interesting work using solar images in extreme ultraviolet region. Several image wavelength observations are taken by two satellite, SDO and also stereo. And those images we analyzed and did the similar type of analysis and calculated the rotation period. Here, the scale is slightly different. That on y-axis you have latitude. This is 0 here, and this is the northern hemisphere of the sun. And from 0 to lower is the southern hemisphere of the sun. And on x-axis we have the temperature responsible for the particular extreme ultraviolet emission. And this temperature is given in the unit, logarithmic unit. So this 5.8 means 10 to the power 5.8 or 10 to the power 6, 6.2, 6.4, up to 10 to the power 7 degree Kelvin. And the rotation period derived from these images is plotted here in the form of this color diagram. The blue indicates, dark blue indicates 24 days, and as you go to lighter, that becomes 25, and greenish becomes 25, decreases, and this becomes 26, 27, and this is 27 and a half. So that is the kind of scaling that you see. Here again, at the equator, on an average, you see that the rotation period is low. And as you go to the higher latitude, the rotation period increases and also increases this side. But this work interestingly shows that there is a systematic variation as a function of temperature. Which also represents in some sense the height in the solar atmosphere. That as the temperature increases, the average rotation period decreases. So that is this work is published in MNRS recently by one of our colleagues and several of us. Now, let me change the topic to slightly different aspect of the space, and that is more relevant to the observation of remote sensing, meteorology, and large part of communication that we have. And this picture is from Creative Commons Corporation's website, and what it shows is the Earth here on the center, and many satellites like this one. ISS is the International Space Station, Hubble Space Telescope, which is basically used for astronomical observation. And then you have Iridium here. You have many satellites that go. In fact, this was on their website is a movie which also shows the rotation period of these satellites. And the period information is mentioned here, that if the satellite is at this height, the rotation period will be 5 hours. Here it will be 10 hours, 15 hours, 20 hours. And in the geostationary orbit, the rotation period will be 24 hours on a day. And so any satellite which is in the geostationary orbit, it rotates around the Earth in 24 hours. And that is why that appears to be stationary in space with respect to the Earth. We always see it at the same point. So that is called geostationary orbit. And there are large number of satellites present there nowadays. Several are there from India and many other countries, US, Europe, and almost all countries. And some countries, even if they do not have their own space facilities and programs of large scale, they got their satellites made in collaboration with a country where the space technology is available, and have them launched and use these for communication, use these for remote sensing observations, use these for meteorological observations and Earth resources observations and so on. Basically, the orbits can be categorized in 3 categories. One is the geostationary orbit, which is the highest for Earth observation. And then you have a medium Earth orbiting satellite called MEOS. And so that is somewhere in this region here. And then the low Earth orbiting satellite. They have different kind of application advantages and disadvantages. One of the basic, 2 very basic information I would share with you. One is that this low orbiting to medium Earth and geostationary orbit satellites, as you go this way, they are the amount of energy that you require to put this in low Earth orbit is the least effort, least energy will take, and the satellite can be deployed there. Medium will take much more than that, and geostationary will take even more efforts, more energy to put a satellite there. But then the advantage is that geostationary satellites or satellite in the geostationary orbit will last longer. Medium Earth orbiting satellites will last slightly less, and low Earth orbiting satellite have a tendency of getting lost faster. So these are advantages in this one. But the other advantage of low Earth orbiting satellite is that you can easily go there and change, remove, make changes in that. They are approachable, easily approachable from the ground. Like the space, International Space Station, as well as the Hubble, they were being approached. They are being approached several times, and newer things have been placed on them and have been improved. Let's go to the next slide, where I will show you an example of our own Earth from space. This is the beautiful Earth that you see, the image taken from the satellite. So very beautiful. You see here, this is the continent Australia. India should be somewhere here. There are clouds on this. This is Africa, and this is the southern island, and so on. So very, very beautiful picture. Several pictures have been taken, but on this Earth, the life, though the researches have been carried out in search of life on several places, on several planets or even beyond, but the only example that we know of today is the Earth-based life. And this, though the living species are very diverse in nature, there are all kinds of species that live on the Earth, beneath, in the oceans, in the atmosphere. So they are varied. But one thing is common, that they all consist of cells and DNA, etc. And based on these, the scientists have tried to develop models which like what are the necessary conditions for life to be present or evolve there or sustain there. And this is the kind of model that if you have a star here in the center, because the star is the main source of energy, and so this energy will be more in this region. So this region near this star will be very hot. The temperatures could be hundreds of degrees centigrade. So if you have a planet in this region, that will not sustain water. That will not be able to have water in liquid form. And one of the conditions for life to sustain, evolve, and be there is this, that there should be water in liquid form, which can be there only if the temperature is between 0 degree to 100 degrees centigrade. And that is this region, habitable zone around any star that you have. And with this, there are efforts to search for planets around other stars. That program is called Exoplanet, search for stars in extra solar systems. And many, in fact, several thousand planets have been discovered now. Some are probably close to the habitable zone as well. And the more studies are being carried out to understand that how we can really make out that whether they can really support life or they have life in some form or the other. These studies are going on. The other study based on the space research is an example that I show here. In fact, this diagram and the next diagram I have taken from lectures of Dr. Prakash Chauhan of Indian Institute of Remote Sensing. Recent talk he gave, and that was made live. So I have taken this slide from his lectures. And here 2 maps of India are shown. This map of India is an average aerosol optical depth measurement during 25th March to 5th April of 2019. This is done by a satellite called MODI satellite. And the contours, the colors that you have here indicates the different kind of optical depth. Like the yellow color is a very less optical depth, say something like 0.1. And as you go towards the red, it becomes 1 or more than one aerosol optical depth. So more optical depth means more aerosol. Less optical means the less amount of aerosol present in the Earth's atmosphere. And this picture is on the same scale as shown below, but this is from 25th March to 5th April, the average of these 10 days of 2020, and we had lockdown because of the coronavirus. And you can see, you can compare these 2 maps and learn that because of the lockdown, our transport system is very meagerly used, very less used, and they're all the highways are empty, all the city roads are empty, so no emission from these vehicular emission. Air flights are also almost not there. International flights also are closed, and the industries, several industries also are closed. Not all, but several industries are closed, and you can see that in these you have more yellow color dominating over India, and whereas in this you have red color dominating a large part of India. And that indicates that the aerosol optical depth have considerably reduced, almost from 20 to about 30 or 40% reduction in aerosol optical depth. Here in this inset are shown the histograms of major cities in India, Delhi, Mumbai, Ahmedabad, and so on. And here the black color indicates the measurements, average measurements during 25th March to 5th April of 2019, and the red color in this represent the same period, 25th March to 5th April of year 2020, that is the lockdown period. And you can see that all the red histograms are smaller than the black histograms for each city, that major cities in India. So this shows that there is a considerable reduction in the aerosol optical depth or aerosol present in the atmosphere. Aerosol is important for us. Aerosol should be there in the atmosphere because that helps us forming the cloud and brings rain to us. But an excess of that aerosol or pollutants gives problem of increasing the temperature of the earth and several other effects that the human will experience. This is another picture from his talk that I have used, and here also again same 25th to 31st March measurement of NO2 and NO2 measurement from 25th March to 31st March of 2020. This is 2019 and this is 2020, the lockdown period and the normal life that we had about a year ago. And here again, you can see very clearly blue represents the less amount of NO2, and as you go towards the red on this is axis, the NO2 concentration increases. This is, in fact, the scale that is mentioned here is molecules per square centimeter, but it is multiplied by 10 to the power 19. So there is a considerable reduction of NO2 column that is present in the troposphere above most part of the sun of our country, India, except that in these are basically spots that you see here on this, and you see many more on this, are due to the thermal power stations, because thermal power stations are still functioning, and they did contribute to generation of NO2, which is present in the troposphere on these regions. But in this region, you see, especially the region around Delhi, UP, Rajasthan, has so much decrease in NO2 concentration over most part of India. So this is a very important aspect that we have learned by the lockdown, because to get this kind of measurement in otherwise were not possible. So these will work, that aerosol optical depth as well as the NO2 measurements in the troposphere will act as the baseline measurements in future for scientific studies. And one of the implication or the bad implication of the more aerosol or more pollutants in the atmosphere is the increase in mean sea level of the Earth, the global mean sea level change, and that is shown here from 1900 to almost present, or very close to the present day. And you can see that from 1900 to 1930 there was an increase in emission in the global mean sea level, but this rise was 0.6 millimeter per year. From 1930 onward up to 1992, the average increase is about 1.4 millimeter per year. But from 93 onward, this increase by two different measurements are shown, one by Nerem et al. 2010 and Watson et al. 2015, and they show these two diagrams here, two variations, but they represent that the average increase in this time period is 2.6 millimeter per year or 3.3 millimeter per year. It's very large. It's almost double than what it was here, and it's
Thank you, sir, for giving very nice presentation. Actually, we all should thank Professor Hariom, sir, as he has given a very nice presentation, and within a short time of period, he has accepted our invitation. You can find more information about his activity on his website. I will send all the details. Even in our website, all this information are available. Now the session is open for question and answer. I have selected many question and answer, and I have pasted on presentation. And during presentation, sir has also marked number of questions, so he will answer. So let me show you number of questions.
Yes. Okay, I'm very glad that there are a good number of questions, and I will try to answer most of them or all of them. Let me read. What keeps the sun spinning? Basically all the objects that you see in the sky, even our Earth also spins around its own axis, and that's how we have day and night. So all the objects that we have in the universe, they all spin around their own axis, and this spinning is in fact in a way gets into it while formation, because most of the objects in the sky are formed by accretion process. The material accretes from sides, and because this accretion may or may not be is usually not uniform, so that pushes one side more and the other side less and sets into motion, and thereafter it remains. And because there is no friction there to stop this kind of motion, so it continues forever. And in fact, not only that it continues forever, with as the age of the star increases, this becomes even faster and faster because more and more accretion. And that is the reason the pulsars are very, very fast rotating object. So in fact, the spin speed of a star, you can estimate almost the age that the star today is and how it will go beyond. How often does the sun's magnetic field flip? The sun's magnetic field flips in almost 22 hours. There is a sunspot number change which takes in 11 years, but the magnetic field lines on the sun changes in 2 such cycles. So that is about 22 years, and that's what the asymmetry of rotational asymmetry that is seen on the sun also has a 22 year periodicity most likely. What is the sun showing asymmetric behavior? Why is the sun showing asymmetric behavior? Does all these stars rotate? Yes, all these stars rotate. That is true. And why this asymmetric behavior is there on the sun is not fully understood, because this was not even known earlier. Maybe about 10 years ago, when this work was published, that was first time. Till then, it was believed that the sun rotates symmetrically. North and south go almost hand in hand to rotate. But when we did this work on X-ray and radio images, there we found out that the rotation rate or the period is not symmetric. There is asymmetry. So this we still don't understand. You can go to the next slide of questions. Is there any? Are there? Yeah. How to measure the sunspots? You mean measuring the sunspot or seeing the sunspot? You see the sunspot if you have a small optical telescope and point it towards the sun and project its image, not see directly through the telescope, but project the image on a screen or computer. There you will see the spots. And people have made measurements of spots in the sense that they count the number, how many spots are there. They also estimate the average area of these spots. So these are the 2 kinds of studies that people have been doing world over, including there is a observatory in India in Kodaikanal. There also the sunspots are numbered, and their number is measured. They also measure the area. There are several other observatories around the world. What is the speed of rotation of the sun? I mentioned that the equatorial part of the sun takes about 24-25 days. In that also there is a variability that we have seen. The photosphere rotates with some detail. The chromosphere, transition region, and the corona, they all do differently at even at different time. But on an average, the equatorial sun rotates 24 days or so, one cycle, And the polar region, if you go towards south or north, that would take something like 28, 30, sometimes even 35 days in some part of the sun's atmosphere. How many dead satellites are available in the geostationary orbit? Will they present in the same position after its life? No, in fact, when we declare a satellite inactive or dead, most of the time that it either goes away from its orbit and is not traceable. But they can be sort of, they loses communication with the ground station. They don't have their own communication system on board, but they can be tracked. There are ways to track those. What is your opinion about photons? Cause photon, the elementary particle, take a major role in both Earth and outer space. Yes, photon do act like a particle, and that is why the impact of photons on the comets and even on our planet makes these tails, magneto tail or dust tail, the kind of thing that I have shown in the third slide of my lecture. Next, please. Can we measure the rotation in normal lab? You cannot measure in the lab, but you can you measure these by observing the sun. You make as I mentioned, that you take a small telescope and say point it towards the sun at say 12 o'clock during the day or a fixed time daily, and take a image. And with that image, you will have sunspot. Tomorrow you do the same thing. You will find that these spots have changed their position. So that way you can assess how the sun is rotating. Earth surface. Yeah, some satellites do come, and once in a while they sort of collide at different places. And nowadays, the space debris has become a great concern. In fact, last year in June, we had the Space Education Research Foundation organized a 4-day webinar series on different aspects of space debris. And most of these debris are because of the satellites that are sent up and they are no more in use. That is one aspect. Of course, there are also natural space debris too. And there are now mechanisms being built to remove these space debris, and that is one concern. Okay, the next question, what is black hole? Though I have not talked about black hole in this topic, in this lecture, but let me say a few words about black hole. Black holes, in fact, are the objects whose escape velocity is larger than the velocity of light. So which means that like our Earth has a escape velocity of about 11 or 12 kilometers per second. But if you have a object which is very, very massive or very, very small in size, the escape velocity would be great if that is more than the speed of light. So any light that gets emitted from that object will not get out but will bend back. The photon will fall down, and that is the object called black hole. What is the name of detector to detect radio waves around the sun's atmosphere? The detector to detect radio waves are the radio antennas or radio dishes that we use in TV and radio communication. Similar to this, of course, they make it little more depending on the kind of application that you have in a different way. But essentially, they are similar to the radio antenna of the radio receivers and TV antennas that we have. Please, okay, what is this? Will you, sir, create an awareness about the surface Earth, in and above orbit of Earth, because we are in need of sense of importance of Earth and etc. Yeah, that is true. Of course, this is not my field, but we have organized from time to time several webinars, and we will also do in future as well. That the Earth's atmosphere need to be studied. We need to be concerned, and things like that. Are there any other questions, or you want me to stop at this point?
Sir, there are a number of questions,
Okay.
but we have, I think, completed 1.5 hours.
Okay.
So many of the participants may not have that much enough data
Okay.
so that they can continue. But
Okay.
I have a number of questions, and I can share with you.
Okay.
And students can personally contact with you, as
That's right.
I have linked your profile with my website.
Okay.
I request a participant, if you have any further question, you can contact Professor Om Vats personally. And
I'll be very glad to answer the questions by email as well.
so again, sir, I'm very much thankful to you that you have spent a very precious time. And
No,
tomorrow,
it is a pleasure to do this activity, and I always enjoy. I always find time to do such activities. Thank you so much.
yeah, I want to inform participants that Professor Om Vats is organizing number of webinars every year. Even I attend his webinar every time. So I will share all the details of participants to sir. So he will inform every time whenever he will organize such type of webinars, so that you can get enough information. Thank you, sir.
You are most welcome. In fact, I can send you the information about our next activity, and then you can share with all of them. There's absolutely no problem. Because it's all for popularization of science and space science, and more it is done, it's always better.
Definitely, sir. We will share all the information with participants.
True.
Okay, sir. Thank you. And at the end, I have one announcement. Due to certain technical issues, and some of the participants have deleted their previous links. Every day now we will generate new links and send to all the participants. So every time we will send new link, and you have to just open and enter your information. So whenever you enter information, your attendance will be recorded. You need not to write your name in the chat box. I hope this information is helpful. And we are also sharing our live sessions on the Facebook page. So if in any case you miss the webinar, you can see recordings, as well as you can watch the webinar on Facebook. If you find any doubt, you can write me anytime. On Saurashtra University website, we have a number of links of our webinars, and even our webinar is live on our website. So there are a number of places where you can watch the webinar. So I think right now we have I think more than 3,000 participants, but in our webinar jam we have around 1,000 participants, and many other participants are watching the same webinar on the Facebook and other platforms. So thank you very much again, sir, and have a good day.
You are welcome. Thank you.
Now I am ending the session, but
Okay.
participants can watch the webinar, the same webinar later. So using the same link, you just have to click on the link, and after a few minutes you can watch the same webinar. Thank you.
You are
Have a good
welcome.
day.